In this OrthoK case, I'll just walk through some sequential troubleshooting steps as we address this case. On the screen are a baseline map in the lower left, and then going clockwise will be the post-treatment map, and then a difference map, curvature mode. So the patient's baseline refractive error is minus 475, minus 150 with the rule, and after wearing the lenses, we're still getting a residual refraction of minus 2, minus 75, oblique axis 45. And looking at the maps, we can see that there's some irregularity. So the first thing I would recommend in this case is to start this patient on non-preserved artificial tears during the daytime. Even a viscous one like Saluvisc I think would be a good idea, probably 2-3 times a day, and see if we can get that tear film a little bit smoother. That will help with quality of vision. It'll also help us assess what's really going on as we follow this patient. So centration is pretty good, possibly a little bit upward, and then on the difference map we can see we're getting areas of flattening within the treatment zone of the lens, some fairly exaggerated, and then some areas of steepening, it appears. I think some of that is just from the irregularity of the tear film, but all in all, the patient is not getting enough treatment, and so we'll need to address that. So aside from the ocular surface issues, one thing I would do is increase the size of the lens. And let me bring the lens up. So here's the patient's lens. It's a freeform lens, 10.3 overall diameter, 6.2, 6.8 OZ and IC positions. On an 11.2-ish or 11.3-ish cornea, I think we can pretty safely go up to at least a 10.9. Sometimes I'll even go 11.0 on a cornea of this size. And a larger lens will give us usually just more room out here in the alignment zone and help to stabilize and center that lens and keep it centered. So I'm going to increase this to a 10.9. So keep in mind that when we change the overall diameter, the software also shifts the position of each control point. So while we started at 6.268, we're now at 6.672. I don't necessarily think we need that large of an optic zone, so I will just drag these back towards the center and put that back to 6.2. At the same time, I'm making sure that I'm not moving these points vertically at all. And this one will go to 6.8. So essentially all we've really done so far is just widen the width of the alignment zone out here. The submitted data indicated that with the lens on, the patient was refracting at minus 75. And so that tells us our initial base curve is a little bit too steep. Could be from these steep areas on the baseline topography. Software looks at data in here to estimate a simulated K and possibly just overestimated based on how the topography looks. So I'm going to immediately flatten the base curve by 3/4 of a diopter, and we'll do that by clicking up at the red control point here. So if we're starting with, say, at approximately plus 150 power, our target is going to be plus 2.25. So I'll click up here. We can see the lens getting flatter, the power changes to compensate, and we're pretty close to a 0.75 diopter change. So keep in mind that when we put this lens on the patient's eye and refract, we're still going to get a refraction of minus 75, because even though the lens is 3/4 of a diopter flatter, Wave software compensated by increasing the plus power of the lens. So if you prefer to have a plano over refraction, then go into the over refraction box, put in minus 75, we'll leave the prism out for now. When I hit continue, we'll see that the base curve does not change, but the power will change. So the power drops back to close to what it was before, but the base curve did not change. Also keep in mind that when we change the overall diameter, your center thickness changes, and sometimes I believe the peripheral thickness will change as well, so I don't remember exactly where it was, but you can set it back to your original values. Now in this case, because we're looking at a total power of about minus 6.25, I think I'm going to want a little bit more central push, and so I'm going to flatten this base curve another quarter diopter. Just to kind of help ensure that we hit target. So far everything's been done in 100% mode. Now anytime we change the base curve, we do want to go through the different meridians, and we can see we're not that close to 175 there, even farther away from 175. That one's pretty close. This one's a little bit over. This one's way over. So even though we were in 100% mode, we can see that the change was not applied uniformly throughout the base curve. And if we go to the back surface view, it's a little bit hard to see, but depending on how your monitor looks, we can see that there are some spokes of touricity back here, and we do want to get rid of those. So in essence, we'll go into 25% mode, and we just fine-tune each of these meridians. Okay, so now that one's pretty close. That one's good. That one was already good. This one we want to back off a little bit. And then we're going to do that all the way around. I'll finish up, but I'll pause the video because we don't need to watch that. So now I've gone through and fine-tuned each available clock hour. If we watch the display down here as I kind of go around, we can see it's fairly uniform all the way around. So I'll go back to 100% mode now, and then we'll make some changes to the periphery of the lens. So going back to our maps, we can see how well the lens is aligned in the periphery. And when doing this, definitely make sure you're looking at a difference map. If we're just looking at a post-treatment topography and we see a lot of blue out here or green, it's not. It tells us it's flatter than other parts of the cornea, but what we really want to know is what change are we affecting by the use of the lens. And so the difference map is where we want to look. And it's not sealing off too well, so there's some flattening, but not a whole lot out here. A little bit more in this area, which looks better. If we zero in on this area, what I see is more touch or more applanation out here towards the edge of the lens, and as we go towards the center of the lens, that kind of relieves, where we're not getting as much press, as much flattening as we head towards the reverse curve. Back to the lens, how that translates to the lens view is, especially in that area where we were seeing some flattening, is suggests that the lens on the outer half of the alignment zone is pressing down on the cornea a little bit more than the inner half of the alignment zone. And generally we want that to be fairly uniform. So we'll make an adjustment, and overall we'll want slightly more touch across the alignment zone altogether. When we're making changes out in the periphery, I think it's most helpful to think about changes in terms of depth, sagittal depth in microns, as opposed to curvature. So if we right click, we can see that right now we've got a depth of 773 microns at the blue control point and 1750 at the pink control point. If our target is to get more touch here and maybe just a little bit more touch here, in other words, we want more applanation here than we do here, then we're going to need a greater change at this control point. And we'll still push this one down toward the cornea a little bit more, but not quite as much here. I like to change it in increments of 7. So what I'll do is aim for a target of an increase of 14 here and an increase of 7 here. So our endpoints will be 787 and 1757. So I'm going to go into 4x just to speed this up a little bit. 100% mode. We're almost there. So, oh, we got a little shift in the position there. Let's see if that changes it. So what happened here is we click down, we increase sag out here, but if we look at the value, we're at 782 and we started at 787. So numerically, that's kind of weird. We ought to have a larger number than before. And what happened is we just started from a kind of weird place. So if we go to the back surface view, we can see in this meridian the steepens into the reverse curve, and there's a smooth, sharp transition as it flattens out into the alignment curve. If we look at the opposite side here, we can see that transition comes in steps. And so this is just a little hiccup in the calculation. And so if we start with something like this, we sometimes will get a weird number at the end. I know that I click down about 8 to 9 clicks, and I know that will result in a 7 to 8 micron increase in sag at this point. The other thing to do is just to find a starting point where we don't have this step. So for example here, if we were to use this as this meridian as our starting point, which is here, then those numbers will match up. That's something that generally happens only here at the blue control point where the reverse curve is, but it will still give us pretty much the same results. If we look at the pink control point, we're now at 1762. If our target is 1757, then we actually need to lift that a little bit. So right now we're at 1762 at the pink control point. If our target was 1757, then we need to back off on that a little bit. So we're actually going to lift here, and one more. So now across the entire alignment curve, we have increased sag, but the change we made at the outer half of the curve is slightly less relative to the change we made over here. It does look like we have a lot of central clearance now, which is okay. Ultimately, we want a lens that's going to work well for the patient, more so than a graph that looks really good. So at this point, I think this lens is ready to be saved and ordered and followed up on the patient.